Hi everyone, in this video we're going to be talking about how to simplify radicals, and we're also going to introduce complex numbers. So whenever you have this symbol, a lot of times we call it a square root, and that's actually called a radical sign. And it's usually a number right there on the hook on the corner, but when there's no number there, it is understood that that number is 2, which is why a lot of times we call it square root. The number under the radical sign is called the radicand, and that little number is called the index. So usually when you see the symbol, it means square root, which is why we say the square root of 4 is 2, because basically this is saying what number can you multiply by itself 2 times to get 4. So in today's lesson, we're going to talk about how to simplify square roots without a calculator. And we talked about perfect squares in our previous unit, and we said a perfect square is a number you get when you multiply a number by itself. So this is a list of the first 20 perfect squares, and so we're going to be using that when we simplify square root. So the steps to simplifying square roots, please get out your notes and fill these out. You want to list all the perfect squares that are less than the radicand. Then you want to determine the biggest perfect square that can divide evenly into the radicand, and then rewrite that radicand as a product of that largest perfect square and another number. Then you simplify the perfect square and then keep the non-perfect square under the radical sign. If you have numbers outside the radical sign that are, you can multiply or divide those numbers, and then you can also multiply and divide numbers that are under the radical sign. So we're going to look at some examples. So in this example, and keep in mind you're doing this without a calculator. Okay, so you have the square root of 20 and you're asked to simplify. So this is the list of all the perfect squares. You're going to look for all the perfect squares that are less than 20, and in this case it's 1, 4, 9, and 16. And then you're going to rewrite 20 as a product of a perfect square that's less than 20 and another number. So the only perfect square that's less than 20 that can divide evenly into 20 is 4. So I can rewrite 20 as the square root of 4 times the square root of 5. Now 4 is a perfect square and the square root of 4 is 2. So we're going to take the square root of 4, and since 5 is a non-perfect square, we're going to keep it under the radical sign, and so this will be your final answer. Okay. Same thing here, you want to simplify the square root of 60. You look at all the perfect squares that are less than 60, and you want to think of the biggest one that can divide evenly into 60. So the biggest perfect square that can divide evenly into 60 is 4. So I can rewrite the square root of 60 as the square root of 4 times the square root of 15. The square root of 4 is 2. 15 is not a perfect square, and so you keep that under the radical sign. So let's say you couldn't think of the biggest perfect square that can divide a number, and you have a number under the radical sign that's still divisible by a perfect square. You still want to simplify that even further. All right, in this example, you have the square root of 300. And if you look at all the perfect squares that are less than 300, you want to see if you can find the biggest one that can divide it evenly into 300. And in this case, this is 100. So I can rewrite the square root of 300 as the square root of 100 times the square root of 3. The square root of 100 is 10, so you take it out because 10 is 100 is a perfect square, and this is the same thing as 10 square root of 3 once it's simplified. All right, pause the video and try this example. See if you can figure out how to simplify the square root of 128. So once again, look at the list of perfect squares, and you can always write this list down if you don't have them. So I know that I can try to figure out the biggest perfect square that's less than 128. In this case, it's 121, 100, 81, 64, and so on. So you want to go from the biggest and see the biggest that can divide 128. So I can rewrite the square root of 128 as the square root of 64 times the square root of 2. The square root of 64 is 8, and 2 is not a perfect square, so this will be 8 square root of 2 simplified. All right, so in this example right here, we have 2 times the square root of 12 times 2 times the square root of 3. So anytime you see a number outside a radical sign that's not like the little index number, that's multiplication. So all of this is straight multiplication, and 12, I can rewrite 12 as, so this is something as saying 2 times the square root of 4 times the square root of 3, because I can break down 12 to 4 times 3. 4 is at a perfect square. And then times 2 times the square root of 3. So this is a perfect square. We're going to take the square root of 4, which is 2. So it's 2 times 2 times the square root of 3 times 2 times the square root of 3, which is over here. Now, all of these numbers that are not under the radical sign, you can multiply them all together to 2 times 2 is 4, times 2 is 8. And then the numbers that are under the radical sign, you can also multiply them together. So the square root of 3 times the square root of 3 is the square root of 9. Well, 9 is a perfect square, as you can see over here, and the square root of 9 is 3. So I can rewrite this as 8 times 3, which is 24. So now it is completely simplified. All right, this example, you have 3 times the square root of 36 divided by 6 times the square root of 4. 36 is a perfect square. The square root of 36 is 6. So the numerator is the same thing as saying 3 times the square root of 36 is 6, divided by 6 times the square root of 4 is 2. 3 times 6 is 18. 6 times 2 is 12. And then you want to make sure you simplify or reduce all fractions. So I can divide 18 and 12 by 6. So 18 divided by 6, 12 divided by 6. 18 divided by 6 is 3, 12 divided by 6 is 2, and so this will be your simplified and final answer. Next, we're going to talk about the imaginary unit I, and the imaginary unit I is the square root of -1. So if you try to put in the square root of a negative number in your calculator, you will get an error message because you cannot take the square root of a negative number. Basically, you cannot multiply two negative numbers to get a negative number. So which is why we cannot take the square root of a negative number, because anytime you multiply two negative numbers, for example, -2 times -2, you get +4. Okay, so you cannot take the square root of a negative number. So as a result, we have the imaginary unit, which really is the square root of -1. Now, if I square this imaginary unit, so if I raise this to the second power and raise this to the second power, square root and square are inverse operations, so I squared is -1. So in math, anytime you see I squared, you have to replace it with -1. And also, if you have a negative number under the square root symbol, you can rewrite this as the square root of a positive number. So for example, the square root of 25 times the square root of -1. So this will be the square root of -5. So complex numbers and numbers that have that imaginary unit I next to them. Okay, so if you have a question like this is how you would rewrite it. 25 is a perfect square, so I can say the square root of -25 is 5. The square root of -1 is I, so this is going to be 5I. That's the answer. All right, here we actually simplified the square root of -75. So the first thing we're going to do here is rewrite the square root of 75 as the square root of 75 times the square root of negative 1. Okay? So always remember that if you see a negative under the radical, your answer should have the imaginary unit I next to it. Now we're going to think of all the perfect squares that are less than 75. And in this case, you start from here. These are all the perfect squares that are less than 75. And the one that can divide evenly into 75 without a remainder is 25. So I can rewrite the square root of 75 as the square root of 25 times the square root of 3, and the square root of negative 1 is I times I. 25 is a perfect square. The square root of 25 is 5. So we're going to put our answer as 5 square root of 3. And then you can put the I. Make sure the I is on, it's not under the radical. Or you can write it as 5I square root of 3, because all of this is straight multiplication. All right, pause the video and try this next 4 problems and see if you can get the answers right. Okay, so square root of negative 8, I know my answer is going to have an I next to it, so I can just write an I. It's the square root of negative 1. So all I need to do here is simplify the square root of 8. Now the biggest perfect square that can divide 8 is 4. So square root of 8 is the same thing as the square root of 4 times the square root of 2. We already have the I there. Square root of 4 is 2. So this is going to be 2I square root of 2. 5 is not a perfect square, and there's no perfect square that's less than 5 that can divide evenly into 5. So all you have to do is rewrite this as the square root of 5 times I. You can put the I here. You can put it as the square root of 5 times I, as long as the I is not under the radical sign, because we already took that out as the square root of negative 1. Okay, square root of negative 150. So we want to break down the square root of 150. Okay, I know that this negative 1 is going to end up being an I. Okay, now if you cannot think of the biggest perfect square that can divide into 150, you can just start dividing 150 by the biggest number you can. Okay, so I know that the square root of 150, I can write that as the square root of 75 times the square root of 2. Now I can break down 75 as the square root of 25 times the square root of 3, and then I already have the square root of 2 here times the square root of 2. Now 25 is a perfect square. I know the square root of 25 is 5, so that simplifies as 5. The negative 1, I'm going to write that as in my I. Now square root of 3 and square root of 2 are still under the radical sign, so you can multiply those. So that's going to be the square root of 6. Now there is no perfect square that's less than 6 that can divide into 6 evenly, so this will end up being your final answer. Okay. Square root of negative 180. Okay, so I know that I'm going to take out the imaginary unit I, so I can say that's the square root of 180 times the square root of negative 1. All right, in this last example, let's say you had to simplify this and you cannot think of the biggest perfect square that can divide 180. You can break down 180 as the square root of 90 times the square root of 2. We already know that this is going to be I. Now, the square root of 90, you can break that down to the square root of 45 times the square root of 2, and then we already have this one here times the square root of 2. You can keep going. The square root of 45 is the same thing as the square root of 9 times the square root of 5 times the square root of 2 times the square root of 2. Now the square root of 9 is 3. 5 is not a perfect square, and there's no perfect square that can divide 5 evenly, so we're going to keep that under the radical. Square root of 2 times the square root of 2 here is the square root of 4, and we know that the square root of 4 is 2. So this simplifies to 3 times the square root of 5 times 2. Square root of 4 is 2. Remember, numbers that are not under the radical, you can multiply them. So 3 times 2 is 6, and the final answer will be 6 square root of 5. So that's how you simplify radicals. Make sure you pause the video and rewind and complete your CYUD 2. Have a nice day.